Welcome back, guys. So this is question 43 of our book, which is Probability and Random Processes by Alberto Leon Garcia, and the edition we have is the second edition. So what is the question here? So you win a lottery ticket if you correctly predict the numbers of 6 balls drawn from an urn containing balls numbered 1 to 49. Okay, so all the numbers, there are basically 49 balls, and the numbers written over those balls are from 1 to 49. So this basically sampling is without replacement and without regard to the ordering. So whatever order you will have, if you predict that correctly, you will win the lottery ticket. So how many possible orders are there? So here inside this urn, so suppose we have this urn and here we have different balls, okay, and over each balls there are written some numbers from 1 to 49. So basically we have how many numbers here? So in sample space we have numbers from 1 to 49. So there are basically 49 balls here. So a person has to pick 6 balls from it, and he has to predict the numbers correctly in order to win the ticket. So how many ways can he pick the balls from here, so that there is no replacement and no ordering here? So this is clearly the question of the combinations. So the combinations here are basically NCR. The N here is basically 49, R is here 6. So how many NCR are here? So 49 factorial divided by 49 minus 6 whole factorial and multiplied by 6 factorial. Okay, so this would be the equation here. So now writing it, 49 multiplied by 48 multiplied by 47, okay, 46, 45, 44 and then 43 factorial. Why did I write it like this? It will be clear in a while. So 49 minus 6 is 43 factorial, and it will be multiplied with the 6 factorial. So these two will cancel out, and at the end these things will remain here. So 6 factorial is basically how much? Writing it here, so 6 factorial is, where is the factorial here? That is, so 6 factorial is 720. Okay, so that is the 720. Let me multiply these terms. So 49 multiplied by 48 multiplied by 47 multiplied by 46. There are also other very feasible and easier methods for calculating it, but I am doing all these steps in order to clarify it to you that how these systems and these things work. So 46 multiplied by 45 multiplied by 44. Okay, so the answer it will have will be this one, and dividing it over 720, what I will get? I will get this number. So there are basically these number of possibilities here, and you will clearly see that this is now how much? 13, 98, 38, 16. Okay, so this is a quite huge number. I am not going to write it here, but this is basically very quite huge number, and any one of these combinations will be the answer here. So you can very easily see that the probability of predicting the number or predicting the sequence of the 6 balls is very low. So the probability of winning a lottery is also very low. Okay, so these type of tactics are used in the lottery winning systems and in gambles, where the predicting any numbers or any sequence of numbers is very hard, and it will give the ultimate advantage to the bar or to the casino where that game has been played. Okay, so this is about our question number 1. Similarly, in question number 2 here, what is it asking us? That find the probability the sum of the three tosses of a die is 7. Okay. So if in order to calculate it, what we have to do, first of all we have to write all the sequences which are available in the sample space. So as we are basically tossing the die 3 times, so writing all the combinations here will be quite hard. Therefore what I'm writing here, so how many items will I have, or how many sequences will I have in the sample space. So initially I have 6 choices in the first place, similarly 6 choices in the second place, and at the third place I also have 6 choices. So this is basically 6 raised to power 3. Okay. So in sample space I have these number of items here. Okay. So we have to find the probability that the sum of the outcomes of 3 tosses of a die is 7. Okay. So what is that? Let me call it that equal to A, and what would be those items? So that those can be 1 and 6. Okay. Similarly 2 and 5, 3 4, 4 3. Okay. These are the items, and you can see that the summation of each of these terms is giving me 7 4 3. And similarly here we will have 5 2, and at the end we will have 6 1. Okay. So these are basically the number of items here. So how many items do I have here in A? So these are 1 2 3 4 5 6. So the number of items in A are basically 1 2 3 4 5 6. These are 6. So what is the probability of sum of 3 tosses is 7. So probability of A is that would be the number of items in A divided by the total number of items in the sample space. So the number of items in A are basically 6, and the number of items in the sample space are 6 raised to power 3. So these are 6 raised to power 3, and ultimately I will get 6 raised to power 2, or this is 1 over 36. Okay. So that is the probability that the outcome of the 3 tosses of a die is 7. Okay. So with this question I am leaving you practice over all this stuff, and I will see you with some more question in our upcoming video. Thank you so much.